All right, welcome everyone. Thank you so much for joining today for Take Advantage of Your Vertical Surfaces with Building-Integrated Photovoltaics. My name is Bo. I'm with Acelab. We're helping out hosting today's event that's going to be presented by Terri Oswald from Mitrex and Cloudify. We've also got Tonya on. She's going to be able to help out with answering some questions throughout today's event. So just want to encourage folks to please submit questions to the Q&A throughout the webinar. We will try to save some time for questions during the end. I know last time we ran this event, there were a ton of questions, so definitely submit those throughout the presentation so that we'll have a record of all of the questions in case we don't get to your question. I'm just going to go ahead and give a quick intro, show you guys how to find Mitrex and Cloudify on Acelab. That's a great way to get in touch with them if you have any questions after the event that you don't think of during today's webinar. And then I'm going to pass it off to my colleague Armand, who's going to give a quick introduction about some of the ways that Acelab works with architects. So that'll only be a few minutes, and then we'll get started with the CEU portion of today's event. So on Acelab, you can search through any of our product categories using the search categories in this dark blue bar up here. But if you know exactly who you're looking for, you can just go ahead and type that into the search bar, head over to their page on Acelab. And right here, you've got a direct button to contact Terri. So this is a great way to get in touch if you've got any follow-up questions after today's event. And you can explore more about their products right from this page as well. So it's a great place to come and just follow up on the learnings that we're going to be talking about today. All right. A few housekeeping items for me. We did ask for AIA numbers during the registration. I will send over a form just in case you're worried you didn't give us your AIA number. You can also request a certificate through that form. So keep an eye out for the chat and I'll send that over to you. All right, and without further ado, I'm going to pass it off to Armand. He's going to give a quick little intro about Acelab and some of our programs that we have for architects, and then we'll go ahead and get started with the AIA portion of today's event.
Yeah, thanks, Bo. Hi, all. My name is Armand, and I'm the Director of Architectural Partnerships here with Acelab. I myself am a licensed architect that's been working in the Northeast for a few years with experience at firms like KPF and more recently Bernheimer Architecture, where I focused on multifamily, affordable residential work across the outer boroughs of New York City. And so what I do with Acelab really is work with architects directly, not only to assist with helping use the platform, but also more direct hands-on product research for projects that you have in the pipeline at the moment. So what I want to talk to you about today is our product concierge service, which is effectively a kind of a free consulting service that we offer for the entire Acelab user base and all of our partners. The way that we really work with firms is by acting as an extension of your team. This is kind of the biggest part of what I do here with Acelab. We join your team and we help inform your product selections, which I know save a lot of time, especially when it comes to reaching out to different manufacturers, vendors, reps. Sorry, did you have a no? Okay, well, that's all right. I just heard someone speak, but that's okay. But anyway, so this is what the product concierge is. And really, while I'm the conduit that works with you, we also have this entire team of product and specialists and experts in-house, ranging from spec writers to architects that can help out with challenging material issues as you're sourcing products in your project. So some of the examples of things that we offer through the service, run the gambit. A lot of it is different variations of how you do product research. A really common one we help out with is just general design material research. Say you're looking for a particular facade that you want to look like concrete, but don't know really where to start. This can be, early during SDs. A really popular question we get is, a faux concrete facade. And the way that we help out here is identify what that look is, and then come back with some options that, hit the budget that you're looking for, hit the sustainability performance criteria, and overall, match that design intent for architects. And some of the suggestions we were able to give are limestone plaster washes, maybe fiber cement panel manufacturer, and then some high performance concrete options that really hit the needs of architects. Other examples of things that we do are comparison reports for products that you're looking for a certain optimization. So you're looking for a healthier alternative to, say, lacquer in this case. we're able to go out, identify a few manufacturers, and then give you the few options that we recommend so that you can make a smart decision for your project. And then we'll go reach out to manufacturer reps. A couple other items include like substitution studies. Say, the budget's looking expensive. I know value engineering tends to happen in projects. So we'll also help out with finding the correct manufacturer and connecting you in a way that makes your projects a little bit easier to work on down the line. And finally, some of the toughest things are to reach out to a series of manufacturers and do all this work to understand your project. So we have a vast network of reps that we work with, and we're able to speak with them regularly, identify issues, and learn more about their products. And so we can really answer the questions that you need, and then ultimately also connect you with those reps if you're looking to get even more information on their products. One last thing that we do offer as part of the service is also help you build your material library. In early 2024, we'll be releasing our virtual firm library feature, which you can do at the moment. This is kind of a supercharged version of that we've learned from our users. And so we'll help you build this library once you start identifying these products that you're liking. And so as we work with you through the project process, identifying material challenges, we'll also learn about the products you really like. And we'll make sure to note that these are products that we should keep in your library because we're seeing you specify them over and over again in your projects. So jumping to kind of how this process works, we work with 40 to 50 firms doing this hands-on work, and we're expanding to many more firms now, which is why I'm reaching out to you today. It's really simple. After this, Bo and I will drop a link in the chat. I think Bo, I don't think you have yet, but I'll do that right after this conversation. Oh, thanks. But you can set up a kickoff through that link during which we'll talk about a project that you want to, or multiple projects you want to talk about and do some research for. And then during that, we'll set up a bi-weekly check-in. So what we do is we meet every 2 weeks where you bring some of the material challenges you see on these projects, or in research requests, information requests. And then in the 2 weeks in between, we'll go off and find some recommendations, get information from manufacturers, and then come back to you with a couple recommendations or connections. And during which point you can also give us more material challenges to start exploring. This is effectively, an hour of your time a month, but it often saves a lot of architects that we work with, 5 to 10 hours of just, early stage material research. So it's been really effective and helpful for various projects we work on. So once you set up that meeting, we'll talk about projects. Feel free to schedule your kickoff at any point. You can also reach out to Bo and I if you're interested in talking a little bit more about this at any point. But yeah, definitely look at the link. I know this is really effective for a lot of architects. So yeah, excited to work with anybody that's interested. But anyway, I think it'd be great to get to today's webinar. Thanks so much.
Awesome.
Bo and Terri.
Thank you, Arman. And yeah, I dropped that meeting link in the chat. So if anyone's interested, feel free to set up a kickoff call with Arman to discuss further. It's a great way to learn more about products like we are going to talk about today. So without further ado, I'd love to pass it off to Terri to get started with the AIA portion of today's event.
Fantastic. Thank you so much both for that. I appreciate that. So let me just share my screen, and I'm going to bring up the presentation, and we can share from there.
Perfect.
All right, is it up and running?
Looks great.
Excellent. Okay, so the name of today's course is Taking Advantage of Your Vertical Surfaces. And the whole purpose of this presentation is to get you to understand BIPV. Combating climate change is a very hot topic, and we need to address that. And we need to address not only the role that the building industry plays in CO2 emissions, but we need to understand how we can shift our focus and think about how we design our buildings and power our community. So today we're going to talk about how BIPVs can be integrated into your projects and what that means from a cost and performance perspective, and how you can integrate this technology into projects. So hopefully by the end of this course, you're going to understand the basics of solar energy, what BIPVs are, and you can describe how they can improve on traditional builds. We're going to talk about how BIPV can be integrated into existing buildings for retrofits or new construction. And hopefully you'll get a better understanding of what the energy savings are. We'll talk about a few case studies in that respect. So sustainability is a topic that we are all engaging in, and for a good reason. But talking about it isn't enough. So the building industry is responsible for a huge part of the problem with CO2 emissions. And unlike some other companies that talk a good game but don't do much, we are doing something about it. It's like saying we should all be driving electric cars. Well, it's up to the manufacturers to make electric cars that are affordable, that the rest of us can buy. I know personally I can't afford a Tesla, so I'd love to be able to engage in that, but that's not going to happen for me. So we put our money where our mouth is, and we're addressing that challenge. And every manufacturer out there should be addressing the challenge of sustainability. So how do we achieve that? Pretty simple, by integrating products into our builds that address those issues. So high performance building systems that actually work and contribute to sustainability. That is what we should all be working towards, and we are achieving that. So I want to talk about the basics of solar. For those of you who aren't familiar with how it works, it's very simple, and it's not new technology. It was discovered in the late 19th century. So essentially, photons carry energy proportional to the wavelength of light. So what that means is a surface absorbs light energy. And with enough energy, that surface is going to release electrons, which create electricity, plain and simple. There's two categories of technology. There's monocrystalline and there's thin film. And a BIPV takes solar cell technology and integrates it directly into the cladding. So that cladding panel becomes your generation of electricity. Typically, the facing starts off as low iron, clear tempered glass. There is a solar cell behind that glass layer, and then there is honeycomb backing. And that is your BIPV panel. The technology varies in the look and the performance. So there's three very distinct categories. There's transparent, there's semi-transparent, and then there is opaque. Essentially, what you're doing is you're converting your facade into its own power generation station. So the facade is going to generate a substantial percentage of that building's electrical needs. So essentially, you're reducing the building's carbon footprint, and you are taking your building from energy efficient to, in many cases, net zero. The technology itself is very interesting in that the coating that's applied to the glass, produces electricity at various performance levels. So whether it is a simple monochromatic color or a replica of an existing building material like a wood grain or a marble or something along those lines, anything can be customized in the facing. So, a client's brand assets like their logo or an address can be integrated into the facing and fully customize it. It's hard to say which color produces what because there's thousands of possibilities, but there's two very simple rules when dealing with BIPV technology. And that is, number one, the darker the facing color, the more power it will generate. And second rule of thumb is that even the lightest color, like white, will generate 8 watts of power per square foot. So you run the gamut from a minimum of 8 watts up to a potential 19 or 20 watts per square foot of power. Now, insulation system options are really important because if you manufacture a BIPV, but you don't know how to get it up on a wall, what's the point, right? So having system installation methods that take advantage of that technology go hand in hand. So there is a rain screen system, which is a stick build or a pre-assembled system. So you can install panel by panel, or you can install, you can have panels pre-assembled to create larger modules, and they are installed on a system that is adjustable. There is insulation behind that. There, in a pre-assembled system, you're dealing with less thermal breaks, so that's a good thing. So that's one option. There's a prefab wall system, which is a full wall assembly, and that is your exterior facing, your vapor barrier, your insulation, your fire stop. The beauty of this type of system is that it installs from the inside of the building, eliminating the need for a tower crane. So what that does for logistics is a beautiful thing. It increases the speed of installation. It reduces the amount of trades on site. There are a lot of benefits to having a prefab wall system. And then a precast system works just like precast minus the weight. It does not weigh 100 pounds per square foot. You're looking at a technology that is roughly 4 to 5 pounds per square foot. 4 or 5 pounds per square foot is pretty light. So that is also a system that will address a lot of logistical challenges. It will reduce the cost of structural steel, required for that type of install method. So there's a lot of perks to that. Solar railing technology is something that can be applied easily to a building. It is probably the least risk for a client. It is so easy to swap out a standard balcony railing with a solar-powered balcony railing. The design flexibility is there. The installation method is there. So there are a lot of things that can be done on that front. And then solar glass in general, different applications, whether it's a curtain wall integration or window wall integration or into an IGU. There are a lot of things that can be done with solar glass as well. We're not a window manufacturer, but this technology would be provided to a manufacturer of your choice, and it would be integrated into their system. The components of BIPV, there's certainly a misconception that in a vertical application, it's a completely different system. It is not. If you're familiar with the rooftop application, it's the same as a rooftop application. The only difference is it's vertical as opposed to on an angle, right? So the inverter and the rapid shutdown is the same. The connections are the same. The only difference is it's on the vertical side of a building as opposed to rooftop, but everything else is the same, I assure you. Connecting to the grid, there are a number of ways to do it. Every state is different with their rules. In some areas, there's FIT programs, feed-in tariff programs. In other areas, there's net metering. In some cases, battery storage is required. There are a lot of different ways, to access and deal with the power that a facade will generate. So it differs from one area to the next. So we rely on the good folks in all of those areas to figure out what that potential is. So the rain screen application is probably one of the simplest applications, especially when it comes to a retrofit project. So I just want to go through what a rain screen case study looks like. So in this particular case, this is a building that is 70 years old that was in desperate need of a facelift, and the client was looking for something that mimicked wood. The panel connections in a vertical or a horizontal application, the wiring questions about how does it connect and how many connections are there and what does that look like, and do you take care of engineering drawings, et cetera, et cetera. Where's the inverter located? How many inverters? Those are all case specific. And those elements get reviewed when architectural drawings are provided, and all of those questions are answered during that process. But what I can tell you is BIPV technology is a simple connection. It's a male-female connection. It is a low voltage connection. So any cladding person who knows what they're doing can connect BIPV panels. And then, what the conduits look like and where the wiring goes and all that kind of stuff. That's all figured out on a case-by-case basis. But I can tell you that, at some point, all of those wires will come together and they will connect to the home run cable, and that will connect to the inverter, and the inverter will connect to the system. So the inverter itself could be any brand. This technology is agnostic, doesn't care. SMA, Fronia, Solar Edge, doesn't care which inverter it connects to. And the inverter itself is roughly the size of a microwave. So it doesn't take up a lot of space. It can be connected into an existing electrical room. There'll be plenty of room for it in a new construction. It could be on the roof. It could be in the basement. And again, those are all, elements that will be covered as you go through the design review process, and those points get addressed. So the benefits of BIPV, what are they? I'd say they're pretty simple. The biggest being the most obvious, it generates electricity. Turning any building into its own power plant is a huge step forward. And that is the biggest advantage to any building owner, is having their facade generate electricity. In some cases, they could be generating, up to 50% of a building's electrical requirements. That's a lot. The other benefit is the aesthetics. Up until now, I have yet to meet an architect that says, yes, I would like that hideous looking panel to go all the way up to the 30th story on the west elevation. Said no architect ever. So the aesthetics are there, and that has been a huge barrier to entry. And now that is available to you. The reduced energy costs, pretty clear that that is there. And the environmental impact, using a sustainable facade is very important, and that is at your fingertips as well. So lots of benefits to using BIPV. And the applications are very simple. After many years of research and development, we came up with one very simple belief, and that is, it doesn't matter what the building looks like. It doesn't matter if it's a high rise or a low rise. It doesn't matter if it's an airport, a hospital, a warehouse. Any surface that's touched by the sun should and could generate its own electricity, period. So that is what the city of tomorrow should look like, in that every building is generating its own power to a certain degree. This is an example of projects where this technology can be integrated. Again, high-rise, low-rise, institutional, data centers, warehouses, the potential is there. Really, it only matters that you have space on your building for cladding. As long as there is space for cladding, there is space for BIPV. And in the area of railing, this is an example of areas that it can be applied and what it would look like. The top right is our own facility here in Toronto. We chose white. And again, for a reason. We do a number of tours regularly, and people keep asking, why would you use white? Isn't white like the worst color? Yes, it is, and we do it for a reason. We pull out monitoring, and you can see what the real live data is on how much electricity it's producing, to prove a point that even light colors generate electricity. So really, no color and no pattern is off limits. And then glass integration, again, curtain wall, window wall, spandrel panels, lots of areas of opportunity. So the biggest area of opportunity really is the cladding in any building. That is by far, your client is going to get the biggest bang for their buck with the cladding. But there are other areas. There are spandrel panels. There's window wall, there's curtain wall. And there are a number of things that we need to consider when you're looking at a building's potential for integrating this technology. Retrofits are a huge market. There is a massive, a stock of aging buildings in North America, in Canada and the US, massive. And what better way to update a building than to give it a facelift with something that's going to generate power for the next 30 plus years. And so there are a lot of things that you need to look at before you consider designing with BIPV. The biggest point that you have to take into consideration is the product that's going to help you reach that performance objective. Only you know, and your client, what you're trying to achieve. If your client is trying to achieve a very small percentage, because I just want to be able to say that we integrated some BIPV, that's great. Okay. You might have a client that says, no, I want to generate as much power as possible. How do we do that? So understanding which BIPV products would help reach that goal is really important. Collaborating with architects at an early stage is super important as well, because color selection is important. Installation system selection is important. Panel layout and electrical design, those are all things that need to be addressed early on. The earlier, the better. So, that's just a handful of the things that are really important to keep in mind. And of course, finding that sweet spot between aesthetics and performance is super important, because a light color will give you some production, a darker color will give you more. So if your client says, I'm trying to get the building to 50% electrical production, and they have in mind to use a white facade, then they might need to reconsider their color choices if they really want to reach that target. So understanding how you can work with your client to achieve that is super important. And then understanding that when a building is assessed, all elevations are considered. There is I would say, a common misconception that it's only the south side of the building that generates electricity. That is so not true. The east and west are super strong, and the north side will generate roughly 30% of what the south side is doing. So we always look at all 4 elevations, so a client gets a true picture of the full potential. In the end, a client may say, let's just go with the south, or let's just go with the south and the east, and that's fine. But it's important for them to know what the full potential is. So we provide that. So hopefully now you have a better understanding of what material selection means and why it's important, why it's so important to work early on with architects, the balance between aesthetics and performance, system orientation, system installation methods, that kind of thing. Super important to understand. Certifications, this is super important because this is probably what sets our company apart from any other organization out there that manufactures similar products, and that is our testing. We have done every testing you can imagine for both building code standards and photovoltaic module standards. Everything for performance and safety on both a building code specification and a photovoltaic module specification has been done. Impact, fire, hail, shear, torque, you name it, we've done it in every way. And so we are certified in Miami-Dade. We have NFPA 285. We have all the certifications that basically make this technology limitless. Unlike some that can't go past the 6th story of a building because they don't have their fire testing, we can go to the 90th story of your structure if required. So it's really important to understand that testing is the hallmark of our success, in that in every aspect we have not cut any corners, and we have taken into consideration all of the important testing required to make this technology safe, for all builds. LEED certification is really important to some architects, not so important to others. Not sure why, but anyway, that is the case. LEED certification is definitely something that BIPV technology can assist with. You could be looking at potential 40 points if you integrate this technology into a build. And governments have come a long way and are continuing to lead the path. We are very jealous of the folks in the US because you have a 30% investment tax credit that your clients are eligible for. We have 15% in Canada. We were supposed to go to 30%, but unfortunately, the Canadian government did not follow suit as they said they would have liked to, but your clients are very fortunate in that respect. And there are other companies that are aligning with sustainability goals. And it's super important that that is an important way to look at the future of sustainability. Every company should be aligning themselves with government initiatives and initiatives that take into account that this is something we should all be doing. Market analysis information is super interesting. The first time I saw this slide, I had to kind of check my vision. I thought I was seeing things, but the fact is this is gigawatt production. Gigawatt production. Look at where we were in 2018 and look at where we're trending towards for 2050. If that isn't an indication that the world trend is moving towards integrating, solar technology, I don't know what else is. And a lot of questions are asked as to why. Why are we trending so much towards that direction? There are a lot of answers, potential, but I think the easiest one and the most relevant one is the cost. The cost has dropped exponentially. And so the worldwide average module prices have dropped about 78%. So in the past, the discussion was, yes, I'd like to integrate that technology, but it's too expensive and none of my clients are going to go for it. But now the cost of integrating this technology is very, very competitive with ACM pricing. So, and ACM, aluminum composite materials and metal panels are sort of middle of the road. And we are very cost competitive with that. And that's before you factor in the 30% investment tax credit. So that's pretty significant. Of course, on the embodied carbon and life cycle analysis, it's pretty simple. So BIPV is a carbon negative product, and it's a building material that not only pays it back its embodied carbon in under 5 years, but it acts as an offset within the rest of the building afterwards. So there you are with your, embodied carbon stats. And from an environmental perspective, it's pretty simple. A building can integrate 100,000 square feet of active cladding and generate 960,000 kilowatts of power in Texas. That same building will do 720,000 kilowatts in Toronto. Or the equivalent of that, it's simple, find a shovel and find a lot of spare time, because that's how long it's going to take you to, reach anywhere near that. So reaching sustainability goals would happen a lot faster if this technology was integrated into buildings. So in summary, I hope now you have a better idea of what the technology is about, the actual composition of the panel, the testing that has been done, to the panels to, put them in a position that they can easily be integrated into a project. You understand the, the advantages, the design flexibility. You understand the carbon negative material that has been used. You've got the lead points, et cetera, et cetera. So hopefully now you have a better understanding of what BIPV is. And as far as, why you would choose Mitrex, that is a question that gets different answers from different perspectives. So for today, from an architectural standpoint, there's a lot of benefits. We have addressed the issue of design. You now have design flexibility beyond what you thought you could ever have. Your lead points are there. Your testing certifications are there. Your ESG and EPD reporting is there. From your client's perspective, they love it because of the warranty. It's guaranteed for 25 years. It is a premium rain screen product, so there is no issue with durability. The government tax credits are there for them. GCs love working with us because it's a lightweight material, and we have various installation methods that makes their life a lot easier. So there are a lot of benefits to integrating this material. So hopefully now you have a basic understanding of what, how solar energy is generated on a surface. You understand what a BIPV is, how it can be used in a new build or a retrofit situation. You understand the money, the savings potential for your client, and you just have a better overall idea of how this technology works and what the potential is. So I'm going to stop sharing my screen, and there we go. And I'm sure you're going to have tons of questions. So shoot, I'm ready.
All right. Yes, looks like we do already have quite a few questions in the chat. So I'll just kind of go through and start reading them out.
Sure.
So first from Jim, are jurisdictional authorities keeping up with the new sustainable technologies? How do you work with them when using advanced systems? Are there any rife protection separation considerations? 3 questions.
Okay, Jim, good question. I'm not sure what you mean by jurisdictional restrictions. Can you expand on that, or?
Yeah, Jim, if you want to expand on that in the Q&A, we'll come back to you.
Okay.
All right, next one. How do you run cables and make connections with BIPV glass windows, handrails, doors, cladding, others?
Okay, so the connections between the panels, whether they are opaque panels or glass panels, is very simple. There's MC4 connectors on each side. It is a simple male-female connection, and the wiring is hidden in a number of different ways. It all depends on the installation method. So if we have a railing situation, the wiring is in the handrail. If we don't have a handrail and it's a base shoe mount, then it's in the base shoe. It's run. All connections, all integrations are seamlessly and invisibly integrated into the build. So you would never see any wires, there would never be any loose wires, or you'd never see connection points or anything like that.
So, and any cost comparisons with silicone-based PV panels?
I'm not sure about silicone based PV panels. Cost comparisons between materials, I can tell you. You know, we are very competitive with ACM panels. So, you know, there are a lot of different materials that you can use on a building facade, but let me simplify it for you this way. Your client has to spend money on a facade, period. Whether they like it or not, they have to pay for a facade. So they have a choice. They can spend $5 million on a facade that gives them nothing, or they can spend $5.2 million on a facade that generates electricity for the next 30 plus years. Plus, they have a 30% investment tax credit coming to them from the government. That's the choice you have. Now, if you're looking on using stucco on your building, we're a premium to that, obviously. You know, so it really does depend on what building material you're currently considering for this project. But we are, you know, not at the lowest end and not at the highest end. We are somewhere in between, and that is very, very competitive.
So, all right. Peter asks, do you have embodied carbon analysis for your products and global warming potential?
We do, and that's information that I can send out. If you want to request information through the Acelab portal, I'd be more than happy to send that out to you.
Perfect, great. Also, just one more note actually on global warming potential. So that's something that Acelab has actually been working on building out data sets for over the past year or so for all of the building products in our system. So if that is something that's important to you to know more about, I'm also gonna just suggest to hit that link for Armand's meeting. That's something that we often are helping out firms with consulting when they're concerned with looking for global warming potential data. So that's information that's not yet live on Acelab's site, but we do have it in the back end and we can access it for firms that we're working with as well. All right, next from Edward, what is the minimum practical size for installation of a rain screen BIPV system? And how does pricing compare to standard rooftop PV solar system, which we kind of touched on, but yeah. Any minimum practical size for installation?
Good question, Edward. So the average size or the sort of standard size, if you will, is roughly 4 feet by 6 feet-ish. We like to work with standard panels as much as possible because it maximizes performance, right? Having said that, we can customize. The more customizability there is, you know, the more cost you are tacking on. So the more you can work with standard panels, the better it is. On a rain screen application, working with standard panels, that's an easy thing. And working with rain screen is simple because it's adjustable and all that kind of stuff. So lots of things you can do with a rain screen application. On a rooftop application, rooftop is very different. Rooftop is BIPV. Let me define the difference. BIPV is building applied photovoltaics, meaning it is an extra cost on top of everything else that's built into this building. BIPV is in replacement of. So instead of precast, you use BIPV. Instead of metal panels, you use BIPV. Rooftop is an extra cost. You have to build extra into the structure of the roof to accommodate the weight of the racking system and the panels. Then you have to pay for the panels. Then you have to pay for maintenance of the panels because the rooftop is on an angle and gravity is not helping you there. So if those panels aren't cleaned and maintained regularly, it is inhibiting performance. BIPV, on the other hand, is a vertical application. Gravity has nothing to do with it. As a matter of fact, there's technology on the panels that every time it rains or rains and snows or rains and winds or whatever, it's self-cleaning. So there's an advantage. You are losing some performance on a vertical application, but in comparison, you're going from 0 to hero very quickly.
Cool. All right. What is the lifespan of a BIPV panel, and does the solar cell lose any efficiency over time?
Yes. So the lifespan, We guarantee our technology for 25 years. So we guarantee that at the 25-year mark, you will still get 80% of the original performance target. 80%. What that means is at the 25-year mark, you will still get a lot of electricity production. How long that will last, we don't know. Our testing is indicating that the panels could last 70 or 80 years, right? That's a long time, but you're certainly guaranteed for the first 25. Efficiency, again, 80% at the 25-year mark. The highest degradation, believe it or not, is in the first year. I don't know why it works this way with the solar cell, but the largest degradation happens in the first year. You're roughly at 1%. And then after that, it is a nominal amount. It is like 0.8%. And that is very gradual over time. So most of it happens in the first year, and then it's nominal every year after that.
Cool. All right. You've noted this to be a rain screen panel. Can it go into a curtain wall assembly?
It's not a rain screen panel. Let me be very clear. Rain screen is an application, not a panel. So we have a rain screen application, we have a prefab wall application, and we have a precast wall application. Those are three different applications. The facing can be anything. The facing can be BIPV, it could be a stone facing, it could be anything. We have active and non-active panels. So the facing is irrelevant. It's the installation method that's important. And so the rain screen installation method is one of three.
Right. And we've got some clarity from Jim on that original question. So jurisdictional authorities are city reviewers and RIFE should be fire. So to go back to that question, are jurisdictional authorities or city reviewers keeping up with the new sustainable technologies? How do you work with them when using advanced systems? And are there any fire protection or separation considerations? That makes more sense.
Okay, so we are, I mean, you know, there are so many jurisdictions, right? Every state has their own you know, government body groups that require different things. So as we work within every state, we are discovering what those requirements are. I think the biggest exposure we have right now is Florida and New York. There are other places we're working with. So whatever their requirements are, you know, we are working with them. As far as fire separation goes, we have NFPA 285. So we have addressed a lot of the challenges, you know, for fire safety. There is no restriction with how high up we can go on this, and we have all the testing to back that up. So if you require specific information on that, then just message me on the Acelab portal, and I'd be more than happy to send you some information.
Perfect. All right, let's see. So Kate asks, yeah, more about the lifespan, but also how much maintenance do they need? Does the electrical production reduce over time? At what point would we expect that they might need to be replaced? So we kind of covered this, I think, but yeah, are there any like expectations of replacement for panels?
Yeah, no, not at all. I mean, you know, it's like any other facade. You may have to replace a panel because, you know, a truck backed into it or something. I don't know. I mean, there's so many things that would necessitate replacement of the panel. But as far as performance goes, I can tell you this: if you've got 100,000 square feet of active cladding and one panel goes down, it's not going to make a difference as far as performance goes. So there would be no need to replace it. And again, there's a bypass diode on the back of every panel. So if one goes down, it doesn't affect the performance of any of the others. If at some point you do need to replace a panel for whatever reason, replacement is, you know, dependent on which system was used. In a rain screen application, it's easy enough to replace panels. If it's a prefab wall solution, it's different because that's a slab to slab connection. We can't just pop it out and replace it. So we would address that concern, you know, when and if that time comes. But there certainly is a way to deal with that if it needs to be done.
Right. Do you offer EPDs for the panels?
Yes, we do.
Right, great. If my electric provider sets 10K max on my home's roof, how would I get them to increase the grid or microgrid to take away the max?
I have no clue how that would work. That is something that, you know, the rules are different from, you know, one city to the next. I don't know how that would work. And we don't work with, you know, the electric company with respect to individual homeowners. That would be rules that would be, you know, citywide. It wouldn't be just one neighborhood or one home. So I'm not sure how I can answer that question.
Well, all right. Let's see. So this person is wondering more about the life cycle of these products, and if you could talk more about the carbon negative of production, where the panels are produced, what pollution or byproducts are produced, and is there any recycle option at the end of life?
Yeah, so we're dealing with materials that are almost 100% recyclable. So the panels are constructed with tempered glass and aluminum honeycomb. So really the only thing that isn't recyclable is the solar cell itself. Not yet anyway. You know, I'm sure that will evolve over time, but you know, the panels are 98% recyclable.
Cool. And they're produced in Canada, right? They're manufactured in Canada as well.
They are. We are the largest manufacturer in the world of BIPV, and we are located in Toronto. Our facility is just over 100,000 square feet, and we manufacture 25,000 square feet a day.
Wow. Very cool.
Mm-hmm.
Is there a list of buildings in the United States that have utilized this product? Or is there a place for case studies, maybe?
Yeah, we don't have a list yet of buildings completed. You know, as you know, as an architect, from the moment you scratch a little design on the back of a napkin to the moment you have shovels in the ground, it's easily a 3 to 5 year process. Our company's been around for 25 years, but we formally launched our solar line 3 years ago. We have a lot of projects in the pipeline that will be completed over the next 2 to 4 years, and then that list will grow. If you go on our website, you can see projects completed. We do have a number that we're working on in the US, so that list will grow over the next year or two.
All right. Are BIPV glass products being considered in the automobile industry? Do you know anything about that?
No. And if they are, it's very hard to integrate because you require a flat surface, right? And I don't know of any car that has a flat surface. Every car has some kind of sexy curve to it or some slope or something. You don't have flat surfaces on a car, number one. And number two, it's small area. Like how much power can you generate if you had one little, you know, or maybe 10 squares on a car? It's the automobile industry is not the best candidate for integration of BIPV.
Yeah.
Not yet anyway.
All right. Do you have clear 100% see-through BIPV panels? And if so, what is their watt per square foot?
We have what we call transparent technology. It is clear in the sense that you can see through it. From a distance, it looks like tinted glass. If you're standing right up against it, you could see the tiny little lines in the cell, but you can see through it. You can maintain vision, but it's not a great performer. 5 watts per square foot is really what you're getting. Not a lot, and it's a much higher cost than standard glass with solar cells in between. So it's not cost effective. It's not something that I recommend to clients. There's some size limitations and not the best performer.
Do you have UL ratings on your assemblies?
Yes, we do.
Is this product certified in California? And do you know if it has been installed in California and in any specific jurisdictions?
As I said, we don't have a lot of projects installed just yet. We are working on a number of opportunities in California. And with all the testing that we have, our understanding is that there are no issues with utilizing this technology in those projects.
Mm-hmm. Is there any magnetic field generated from these panels, and how do you protect users from it?
Magnetic field? No. Nope.
Cool. All right. tell us what vertical PV increases in watt per square foot above the sloped PV.
So, as I said, sloped PV, as in a rooftop application, you have roughly 23% efficiency. In a vertical application, you're looking at roughly 18 or 19%. But in a sloped angle, gravity is working against you. So the slightest bit of layer of dirt or snow or something else, and that sloped PV is now down to 18% performance, which is where we're at with vertical to start. And gravity does not work against us. So we are maintaining that 18% efficiency.
Cool. This person asks, cost competitive with aluminum panels?
Very,
Yeah.
very competitive with aluminum. And that's before the government tax credit.
True. All right, awesome. See, this person asks, are you traded publicly and what is your symbol? And then they say, call me. So
I've never been asked that before. What? No, we're not traded publicly. We are not a public company. Not yet.
cool. All right, another question on lifespan, which we went over, and degradation over time, which we also touched on. All right, so other than that, it looks like we've gone through most of these. Someone else says no questions, just nice presentation. So thank you to whoever said that. Got a few minutes.
Questions? Come on.
I know, we've got a few minutes left, so
Yeah.
feel free to keep firing away. I also noticed now that someone has raised their hand. So Kim, I'll unmute you for a moment if you had something you want to ask out loud. And if anyone else would like to ask a question out loud, feel free to raise your hand and I'll unmute you as well. You don't have to turn your video on, so it's not scary. Oh, she put her hand down. Okay, so no question from Kim then. But yeah, if anybody wants to ask a question out loud, feel free to do so. Sometimes it can be a little easier if you've got like a long-winded one or a project-specific question. We are happy to unmute you.
If anyone is curious as to how we look at projects, it's very simple. It starts off with drawings. If you have a project that you think might be a good fit for this technology, send me the drawings. We'll have a look at it. We'll review it. As long as we understand what the geographic location is, what the intended material is, what kind of color or patterns do you have in mind for the cladding? And then we could run an analysis, very simple, and give you a very good idea of what the budget cost will be and what the performance will be on that building.
Awesome. All right, got a few more questions coming in. Do you foresee government incentives improving or going away in the near future?
Let me check my crystal ball. If I had to provide an educated guess based on my experience in this industry and based on what we hear coming from a lot of events that we attend that have government representatives at, I think we believe that it is only going to increase. Sustainability is not a discussion that's going away anytime soon. This is not something trendy that's just in the news for a 24-hour or a 1-week cycle. This discussion, climate change, sustainability, this is not only here to stay, but I'm sure you've noticed that over the last number of years, it is increasing. And that is something like anything else that is constantly in your face. Government has to do something about it. They are. In the US, we are envious in Canada because the US is stepping up. Now, I do believe that, you know, who gets in power next could have some effects on that. I don't know. You know,
we'll see.
Biden is very much for this investment tax credit. If Trump gets in, I don't know. I don't know what's going to happen. So I can't address that. But we believe that, yes, governments will only continue to add to their programs for sustainability over time.
All right. Is there a minimum size for projects?
Minimum size for projects. How about I ask you this? If it's so small, what difference is it going to make? Right? So if you're just looking at maybe, you know, a few panels, I mean, that's just going to generate enough electricity, to power your cell phone. It has to be a project big enough that it's going to make a difference. So I would say anything less than 5,000 or 6,000 square feet of active cladding isn't going to make much of a difference. So the question really is, what is your client looking for? What are their hopes? What are their power projection goals? Because if it's just to say, oh, look, I have a sustainable facade, but it's only one panel, that's not going to do anything, right?
All right, and kind of related to this question, but somebody asked if this would be good for an individual house. So you all do have like a residential line, right? That is just, you can order directly from the Mitrex Cladify website.
Absolutely. So if you go to Mitrex.com, you will notice that there is residential rooftop solar and residential wall panels. So in this particular case, the application is BIPV. It's an extra. It's added onto your roof or it's added onto your existing wall. If you have a home that's built with stucco, we have wall panels that look like stucco. If you have yellow brick or red brick or black brick, we have panels that will mimic that color. So you have a number of design choices for either wall panels or roof panels that will match whatever existing shingle you currently have. But in that particular case, you don't call me, you would just get online and order the panels and then find an installer in your region.
Right. Cool. This person asks, you may have mentioned this, but does it make sense to put this on the north side of a building?
Absolutely. The north side will work on reflected light. It will generate on indirect light roughly 30% of what the south side is doing, and the south side is the strongest performer. So the north works. Absolutely.
Do BIPV products have the same issue with decreased production in hot weather that traditional PVs do?
That all depends on where the building is located. I would say that we probably would stay away from buildings located right along the equator, because in that kind of intense heat would affect performance. It's kind of like, you know, what happens if you leave your cell phone out in direct sunlight. After a while, it reduces the battery charge, right? It will significantly. So, you know, believe it or not, panels work better in colder weather. But
right.
They still work really well in the southern states.
Is Mitrex developing integral solar for roofing, similar to Tesla tiles, or are roofing solutions always still applied rather than integrated?
Yeah, they're not integrated yet. We're not there yet. You know, at some point it would be great if roofing shingles looked and installed just like shingles, and they were, you know, had solar cells built into them, but we're not there yet.
Okay, cool. Could you speak about how retrofitting existing building facades would work?
Oh God, that's so easy. When you're looking to retrofit a building, the last thing you want to do is find a facade that's heavy to begin with, because you don't know if the building can support it. And secondly, you want the lightest material that you can use, so you're not dealing with that issue. And how great is it that you can have a panel that is super light, so you're not dealing with any extra challenges, and is generating electricity? What better way to give an aging building a facelift that you know, is on steroids? That's basically what it comes down to. You're beefing up the look of the building. It looks fantastic, and now it's generating electricity. And in most cases, old buildings are thermal hogs, like they're just leaking, you know, everything. And what better way to close it up than with something that is not only going to make it look nice, but it's going to generate power and address all those thermal performance issues.
Yeah. All right, awesome. Looks like we've got time for one more. Not sure if we've gotten to this yet. What's the half-life of your solar cell products?
Sorry, what's the half-life?
Yeah.
I don't understand what that means.
Okay, Nick, if you can follow up and clarify what you mean there a little bit. All right, one more then. Do your panels insulate at all?
Not really. So the panels themselves don't have much R value. I think maybe 1.5, 2 tops. The R value really comes from the insulation, and the insulation in a rain screen application, the system is adjustable. So there's a lot of room for insulation there, and we can hike up to R30 if you need. On a prefab wall system, the insulation is integrated directly into the panel. So there's a lot of opportunity there, whether it's outboard insulation or inboard insulation, lots of room to get that to a high R value if that is what you're looking for.
Awesome. All right. Let's see, clarity on that half-life question is the time in years until generated power for the same light intensity halves. No, that might be too much math for us right now, but
forgive me, I really don't understand that question. I am so sorry. I've never been asked the half-life, or I mean, all I can tell you is that, you know, the panels degrade over time. At the 25-year mark, you still get 80% performance, which means you're still going to have at least another 25 years with the panels. You know, as far as, you know, 25 years isn't even the half mark, really, if you're still getting 80% performance. Other than that, I'm really not sure what that question means. I'm sorry.
Well, all good. Well, we'll have a record of it, so we can always follow up afterwards.
Okay, all right.
And with that, it looks like we are at time. So thank you so much, Terri. That was a wonderful presentation, and thank you for always rapid fire answering those questions.
Yeah, absolutely. My pleasure.
Yeah, and thank you to everyone who joined us today. And we appreciate your engagement and asking so many great, insightful questions. And yeah, before I end this webinar, I did drop a few other links in there to get in touch with Mitrex to register for our next webinar. So grab any of those links if you're interested in them. And other than that, I hope everyone has a great rest of the day.
Happy Thanksgiving to everybody. Gobble, gobble.
Thanksgiving. Bye.